Hello, my name is Yevgeny. I'm a technical artist at Giant Software. So basically I'm doing some kind of technical and art stuff. And this presentation would be about making crawlers for Farming Simulator 22. So what does crawler mean? What is it? It's endless track driven by sprockets and wheels used to propel heavy vehicle and enable it to cross soft or uneven ground. So this is a definition of the crawler. So basically it's how it looks in real life. So basically, yeah, well. And this is, next one slide, would be how it looks in a game. So something like this. Another, it's how it looks in a game on the editor, you would say. So, and now I will be explaining, it's more like a tutorial, one by one, how you can actually make it. So, but before starting it, well, basically we have two different implementations of the crawler. One is a rigid, another is soft. Rigid is actually made from individual pieces, like a metal one, and they connect it from these 2 points, and they propel connected ones to each other, and also they usually don't deform, so they metal kind of rigid. It's individual pieces. It's important. Yeah, one is it's a soft. I call it soft, but it's rubber basically connected to each other from the beginning to the end. It's deformed softly on a rotation elements. It's kind of logical. Yeah. We start from the rigid crawlers. Basically, yeah, it's one piece like this, which is duplicated several times. And to make it work correctly and it would be not so heavy, I suggest to make two versions of it. So one is more detailed and another is less detailed. So you can have like and after that we will set up LED system for it. So usually it's about like detailed version is like 350 triangles and simplified it's 70 something or 50. If you can make it lower, it's better. So and we will set up a special system which will switch one model to another based on the distance to the player, to the camera. So, okay. First of all, I will be using Maya. So this is our main software which we use internally. So, and before doing anything, you need to make sure so in the preferences units set to meters because it's important. Yeah, so it's like in preferences. Again, and I'm assuming you already familiar with the vehicle shader pipeline which we have. So because it's a vehicle, you have to use this shader, and if you basically it's like depends on your UV position, it applies different material. So is it metal or is it something else? So, and for crawler, we'll be using a special shader variation, to say, which enables this functionality. The shader variation called motion pass _ second UV _ color mask. So what it does, basically, UV0 as usual, it would be material which is assigned. In our case, it would be used for normal map, and we moved it in a second slot, which is called black metal. And but UV1 would be actually special mask, which we called vehicle mask, which is scratches, ambient occlusion, and dirt applied. So usually you can actually copy the same UVs, but it would be something like you see in the middle, a repetition of the dirt when it's applied. So to avoid this repetition, we actually do, like I suggest at least have 4 different pieces, like and with unique dirt painted on it. So when you export, well, this dirt would be at least more random. So again, UV0, it's for really big details, like a normal map, for example. And UV1, you just copy your UVs and your regular vehicle shader stuff. So if you want to test it before you actually want to apply and do anything, so I suggest to use this another variation which is called second UV _ color mask. So just go open i3D tool. So in order to assign this material, open i3D toolbox, go to material tab, find the shader in a vehicle in a Dropbox, which is called vehicle shader, and and find a view variation called second UV underscore color mask and hit apply. So basically material, so you should have something like in material attributes, this kind of some data added to it. But in case, like, it's not visible enough, but yeah. In case, like, it may happen that you don't have these shaders in this material tab from our game. So you basically need to do it manually. So you can also do it manually. You just need to find material which is assigned to these pieces in a hypergraph in the Maya and add these attributes manually. So you select material, add attribute, and put like one attribute custom shader, and select string as a type and press add. And the same, you need to do custom shader variation as a string attribute, which will be attribute of the material. So it's kind of, sorry, oh, I moved, yeah, it's great. So at the end, if everything is correct, you should have custom shader variation with this pass, like $data underscore shaders underscore vehicle shader .xml, which is kind of telling to the editor or to the game, so okay, you need to load this shader from here. And custom shader variation is saying, okay, you need to enable this code in this shader variation. So it's kind of a second UV color mask. So this is we just did for testing. So and after that you export. And well, you can move them apart before doing, like if we don't have LOD set up yet, so we just move them apart to see how it works. And in parameter called RDT, you can like adjust X and Y code values and to see, okay, my scratches, how they look, dot, how it looks, so it's kind of like this. And okay, now is important stuff. So because it's implemented this way, your pieces need to be aligned in Z, Y plus coordinates. So one small piece would be moving into Z plus direction of the Maya units. So this is like important element. And pivot of these pieces should be not in a point of rotation. It should be in the center of 2 points of rotation. So it's a bit unlogical, but it needs to be for shader to work correctly. So it's usually, yes, you want to make it in a way it actually rotates one of the pieces, but we have 2 points of rotation. So basically, we moved in the center of these 2 points of rotation. So, okay, let's say we have this kind of fake geometry which I made in order to propel these pieces around, or move these pieces around. So I made a quick time lapse how you can make a mesh around which and a spline, let's say, which we will use to generate this extra data. So it's regular polygon modeling. You can take one piece and to try to align, okay, how it physically goes. Okay, can I go here, here? Okay, it needs to be, goes over about here. Okay, and after that, you just physically, like, deleting some parts, removing what you don't necessarily need, extruding. So you basically, first you prepare the mesh, and after that, you can select one edge of this mesh and convert it into the spline. So this is kind of, yeah, you just, yeah, really quickly, usually it takes more time, but it's time lapse. So, it's kind of, it's really quick, and the next slide I will show what I did to kind of convert it into spline. So basically, I made it in the center with some edge, and I went to modify, convert polygon edge into curve. So, and after that, I just closed the curve, so because it should be looped. So, and at the end, what we get, it's aligned at ZY plus. It's perfectly without any plus minus X of Z, because it's kind of shader. It technically can do it, but it's more advanced. We just, okay, it needs to be flat. Okay. Okay, also, if you want to keep this geometry which you are using for modeling for later, for example, and also this spline, so it would not be exported. You just can make like special group call or transform data underscore ignore and put all your data here, and while you exporting this scene, this data ignore will be just skipped. So it's kind of a nice trick to keep your work in progress stuff and don't lose it or don't save it in a different file. So it's kind of, Okay, and for generating this data, so we prepared a script which is called object data from curve. So you go to tools in our editor and run the script. UI should look like this. You just select the spline and press button load. So you should have some kind of full Maya pass written in NURBS section, so which is saying, okay, it's loaded correctly. And after that, what next? Basically, we need to calculate the distance between these two rotation points. So you can use different methods in Maya, but basically you need to physically find how much in units, in meters it actually is. In our case, it's about 0.2 meters, like 20 centimeters. So, and you enter this value into distance, and after that, you press create by distance. So what it does, it calculates points in this spline on the specific distance which we actually specified. So basically, it will generate you how many rotation pieces you need and everything. And it will be exported later as well. So it looks like this. So you have your extra transform and a lot of transform underneath, and in this transform, we actually add some extra data which we'll use by exporter, which is saying, okay, we need to export this position and rotation of these points into special texture, which is called crawler array.dds, and you can specify, okay, I need position and orientation of the points. So it's these two. So, but there is some small trick, which is, it's really hard to explain, but just remember, if your points looks outside, like this Y component of the transforms, it's wrong. It needs to be looks inside, because it's a bit of mathematical stuff, which is, it's basically one case it works, another it doesn't. So you just need to remember it. So, and after that, you can do it like select your spline and right mouse button and reverse the groove, so it will reverse it. And after that, you just select the spline again and generate the points, and it will generate them correctly. So it's inside looking transform. So, okay, now we need to modify our material to say, okay, we actually want to use this shader variation which enable our crawler to work. So basically, we select. Or we use the same material assignment in our tool. So you just select shader and find variation called motion pass underscore second UV color underscore color mask. And you also need to put, you enable mtrack array, and you put this name of this array texture, which was in attributes of the transform, crawler array.dds in here, and press apply. But again, if in case it doesn't work for you, so this shader is not actually displayed over here, you can do it manually again. You just need to select the material and press add attribute and put the long name and short name, select string, and your attribute name is actually custom texture underscore mtrack array. So this is kind of name of the. And again, at the end, you should have something like this. So custom shader is $data shaders vehicles. Custom variation, motion pass underscore second UV color mask, and custom mtrack array, sorry, it's so much text. It's crawler array DDS. So this is, now finally we can test it. And yes, important stuff. In any case, your spline was called differently, whatever. Your texture DDS would have different name. So make sure. So this texture, which is in this transform, which I showed, like crawler array.ignore, is the same name as in shader. So it should be identical, basically. What it does, editor will export the data into this texture from this transform, but shader will be loading this texture already. So it's kind of a separate process. So in case you have different name, you need to actually make sure it's identical. So. Let's do a LOD setup. So I assume you know what is LOD. Well, basically it's just changing one mesh into another based on the distance of your camera. So, and well, we have in our specific case, we have like LOD with 4 different pieces, and name of these pieces correspond what they actually like A1 is B1 simplified, A2 is B2 simplified. So, and before doing LOD system, I suggest to select all transforms, like this sub-pieces, LOD transform and Crowley transform, and just assign default attributes. So, because in this case, you make sure so you at least you have defaults assigned, and after that, did I scroll a bit faster? Yes, sorry. Oh, okay. And now we do set up LOD. So LOD would be controlled with a high transform group, which is called, in our case, crawler. So this transform would be switching between a transform load 0, load 1. So select this transform, open our attribute editor, go into section clip distance set 300. So on a 300 meters, it would be just not visible. Go into LOD section and set and set LOD, enable LOD checkbox and set value LOD1 distance into 30 meters and hit apply. So it will tell, okay, we need to enable LOD switching, and on a 30 meters to the distance to the camera, we will switch from load 1 to load 0, or from load 0 to load 1. So, okay, next we're going to assign another attribute, but before doing it, you just select defaults in predefined UI and automatically change it to default, because you may just forget something and you assign something wrong. So, okay, defaults. Now we select LOD0 and LOD1 and go into rendering tab and select mesh children. Basically what it does, the sub-elements or transformed AI, like, it will be combined into one mesh. So at the end, it would be exported as one geometry. You would not have them separately in editor. But it will add extra data which will need it for shader to map positions of these pieces to the texture. Like, it will kind of say, okay, I am in index 0, it's in vertex, in the pixel 0, it's position here. So it's kind of will move them based on texture. So this indexes is really important. It's why this merge children need to be applied, because we store them in this manner. So what it does on export time, he will basically move all of these pieces to 0, and on the rendering time, basically, it would be mapped back, move them in the positions of the when it's actually on a texture in the space. So, what is happening? Oh, sorry, it's moving. Okay, so after export, if everything is correct, you should have something like this. So it's still 4 pieces, and it's kind of already moves. So you can adjust this parameter called scroll position X. I'm sorry, it's still moving. And it should look like this. So, but yeah, keep an eye on the rotational place. When it rotates, it's actually started doing some wobbling. Like here, for example, you see when it's rotating. Basically, well, it can work like this, but it looks a bit not really good. So why it happens, we have really big distance between these two pieces. It's like 20 centimeters. So basically, we need to increase more data. We need add a bit more data to it. So instead of having 20 centimeters, it should be about like 10 centimeters or something. So what we can do, we can add extra points in our array animation. So instead of having 42, which was generated by a script, we can, let's say, have 84. So twice the size. So to do this, we select our spline, which we have stored before, we load it, and actually instead of generating based on distance, we generate them based on amount. In our case, it's 84. So, and what it will be something like this. So we have 84 points right now. So it should be a bit smooth, this rotation in this kind of places. But what it's also doing, it's also adding more indexes. So we need to reflect this information into our mesh. So because we kind of moved these pieces together, instead of having 20 centimeters, they now 10 centimeters between each other. So which is not really good. So how we can fix it? We just need to add on one fake element in the system, which is empty group. So you just add extra empty transform, and it will kind of tell, okay, it's one more invisible element in the system here. So after the mesh, logic is like this. So you add one, first should be geometry, next one is empty transform, geometry, empty transform, and geometry, empty transform. So they kind of, in this case, it will kind of fakely make them 20 centimeters apart. So, and you need to do it for both LOD0 and LOD1. So it's kind of, and if everything went correct, they should still stay on the same position, but rotation point, when it's rotated, it looks better now. So it's not wobbling like it was before. So it's wobbling because it's doing some linear interpolation, so it's a problem of this. So now we can actually finish all other pieces. We just select these pieces and duplicate it with Ctrl-D several times until we reach what amount which we need. So we had before 84 points in array. So you just duplicate it and delete some which just don't need it at the end. And the same should happen for LOD0 and LOD1, so it's the same kind of process. So ideally, it should be like this. Well, but it hides. This is another problem, we will address it right now. And problem is, because like on the export time, we kind of put all the pieces at 0, but rendering system doesn't know, okay, where's my actual size of me? So I don't know, it's maybe this at the center, your size. And we actually need to tell, okay, your size is bigger actually, not this small. And because of this, it would not clip. So in order to do it, we need to, you just create two simple boxes like this, and call them like bounding box, left crawler 0, load 0, load 1, or some like unique name which you can later understand. And you select this box, and in our attributes, you need to say, okay, I am a bound of, and you specify path of this, what you will be bound of. So it's kind of, and it uses Maya full path to the object. So it's Maya full path is the same like in directory. So instead of having backslash, it's actually using vertical pipe to separate. So you kind of folders. So and we know exactly, okay, our crawler load 0 is lying under transform called left crawler load 0. So you need to start with a backslash, or in Maya style, it's just vertical pipe, left, vertical pipe, crawler, vertical pipe, load 0. So this is a kind of full pass, which is saying, okay, you are actually, your bounding box will be used for this mesh. And you do it for load 0 and load 1. And to test it in editor, you just can simple unparent these two load 0, load 1, move them apart, and press right mouse button, show BBS. And if it's kind of around your mesh, like you should see some kind of round shape, okay, it means everything bounding box is set correctly. So at the end, yes, it should be like this. So this is, if you did everything correct, it should work like this. So, but this wasn't just part of the setup. It was really rigid. You see, all pieces are worked separately. But now we're going to set up different one, which is soft. Soft, it's rubber. It's kind of connected endlessly to one beginning, goes into the end. It's done a bit different. Again, it's the same logic. It should be ZY oriented, and it moves around Z plus coordinate system. So this is important. It's just implementation of the shader. And pivot should be at the beginning of the mesh somewhere, like on the pictures. So it's like that, and it's Z plus oriented. So it's also kind of, Again, we will use vehicle shader, but in this case, variation would be called motion pass rubber. So this is important. And the score second UV color mask. And usually, like it has it should have two UVs. One UV you have for repeating element, which you use for your normal map details. Like it's one repeating element UVs. So if you copy this piece continuously, it would nicely continue. And of course, it's because it's using vehicle pipeline, you need to put it in a different slot to specify what kind of material we want to use. In our case, we use rubber slot, so we just moved it in UV slot, which is called rubber. And UV1, I suggest to have at least like maybe 4 meters or maybe 2-3 meters, which is uniquely mapped. And you can have some unique UV, you kind of paint some dirt on it, so it would be not the same repeating. If you imagine you have just one UV0, you kind of would have the same dirt on every single piece. So you don't want it to have it visually like this. So, but important, this all piece together can kind of, if you copy it, it should be continuously kind of following another one. So again, we do the same test, the second UV color mask, check it in editor, if it's correct, create spline, you have some kind of geometry. Okay, and how this variation works, what it does, it has 10 meters of geometry, so like physically from 0 to 10, and it scales them around the spline, so it's stretched. So basically, if you have a spline which is 7 meters, for example, you need to bake your 7 meters into 10 meters. So this is kind of one problem. And it would be stretched around the spline and connected together. So now I will explain how you can do it. It's a bit of modeling. Basically, you kind of need to, your deformation, need to embed it into mesh, into geometry itself. First we will create this, just to test if this actually work. We will create this, texture data and also test it in editor. So you create your spline, select it, and press create by distance. It will generate you about like, yeah, something like this with maybe 0.1 distance, 0.1 meter distance between points. Yes, and in material which is applied for this mesh, you need to put variation called motion pass rubber underscore second UV color mask, and the same, you apply the color array, crawler array, and you can test. So it does work, but apparently is not whole piece here, so we need to fix it. So, what we need to do, first we need to find actually how long our spline is. So I made a tool in a tool, so it's called get curve length. You just select your spline and press this, and at the bottom you should see some value. In our case, it's like 8.5 meters long. So I will be using cube for kind of modeling. So you just made 1 meter cube, move your vertices in the 0-1 range, so they should be from 0 to 1 in Z direction. So something like this on the picture. And after that, you just put the value in the scale Z, like 8 meters, 53 centimeters. So basically, this is actually physically how much of the rubber you need to wrap around your specific setup. So we know exactly this piece is tileable, so we just duplicate this piece and move it into beginning of the another. So, end of this, and repeat, you need to repeat it several times until you actually cover all of this 8.5 meters. So select all of these pieces, combine them, and merge the vertices. So basically it's default my operations. Combine, merge vertices, and yeah, put some really, really small value in merge vertices so it would not collapse some extra vertices for you. And delete the history. It's just my specific, you just delete by type history, so it's like completely clean. But, and yes, we have a problem. It's a bit longer than we expected, so just delete the piece of the mesh which is not really needed for you, but delete it in a smart way, in such a way so your beginning of the mesh will be continuous to the end of the mesh, or end is to the beginning. So if you copy your mesh and place it next to it, it should be small, like really smooth transition. Should not be gaps and everything. So, and again, it's a bit sticky. If you number 2, for example, it's a bit sticks a bit from our cube. So I suggest we just scale it a bit. So we just do a bit of tweak. So we scale it 0.99. In my case, it was really small value, like 0.999 something. So it fit. So yes, it was. Now you need to you parent this geometry which you made under the cube, and you scale your cube by 10 values. Basically, what you do, you was parent it, and after that it's scaled by 10. Now we kind of artificially scaling the mesh on 10 units, and after that you unparent it. And you select this mesh and apply freeze transformation and choose scale freezed. So in this case, we bake the scale data into vertices. So now it's distorted. It's not longer the same kind of pieces. It's more distorted. But it's needed because we use 10 meters to wrap. So I suggest to duplicate the same piece and move it exactly in 10 units and just align original piece end points to the next duplicated one. So in this case, you exactly know, okay, I'm sure. So after 10 meters, they will be aligning to each other. So this is kind of abstract. And yeah, well, you select, you clean up the scene, remove everything what you don't need, move this geometry somewhere else. Depends on how complicated geometry it is. You may also need to do LOD system for it. In my case, it was pretty decent, like 4,000 or something, so I decided to keep it as is, without LOD. You just need to assign clip distance for this object, like 300 meters, and hit apply. And again, because it's a bit stretched, it would be different bounding box of it, so we create our custom bounding box, just a regular box. And in bounds off, we specify exactly path to the geometry. Like in our case, it's vertical pipe, left vertical pipe, track. So, and everything, if everything was right, you should have something like this, like with displayed bounding box. So it's connected to each other. So something like this, I would say. So it's rubber-based. And you can do it in Blender as well. So yeah, it's a bit, I would say, fragile. So it's really carefully doing it, but it's still doable. So both setups, it's doable. I have sample files, and I hope we'll release them again, so everyone can have a look. And yeah, and if you have questions. Yeah. And yes, don't forget, Blender has different orientation axes. So something which was Z plus in Maya now is Y minus in Blender. So something like, it's just ways of how it's implemented. So yeah, this is basically it. If you have any questions, you can ask.